Hi, Algebra 1. We are going to be looking at lessons 14 and 15, and we're going to be doing outliers, investigating them, figuring out what they mean, and then also we're going to be looking at comparing data sets. In lesson 14 here, we are going to do all three sections or all three activities in the lesson, and then we do have some important things in the summary to review. Here we go. All right, first in activity 1, it's called healthcare spending. I want you to first read the problem and look at these two graphs. They're giving you both a histogram and a box plot, and I want you to just answer number 1. Hopefully you noticed in here that this country right here is going to be an outlier. And we're going to talk about how we know that in a little bit. And one interesting thing is that that country, notice that's only one country that's spending this much per person on health, is the United States. That's going to come up later. So it's interesting that we spend the most per person on healthcare, and yet we're not considered to be very healthy. But going on to number 2. By one rule for deciding a value is an outlier if it is more than 1.5 times the IQR, which is interquartile range, greater than quartile 3. Now this is very wordy, so here we go. We're going to be looking at the box plot for this specifically because the IQR can be found right here. And we kind of have to do a little estimating here. We notice that it's going to be a little bit less than 3, so we're going to call the IQR 2.7. And so to determine if this really truly is an outlier, we're going to take our 2.7 times 1.5. That's what they mean by 1.5 times the IQR. And that is going to be 4.05. Okay, so now we take that 4.05 and we're looking at, is my value more than that distance away from quartile 3? Remember, this line here was quartile 3. So a little bit less than 5, add on just a little bit more than 4. I'm going to get almost to 9 here. I'm just going to put kind of a dot there. And since this value, our maximum value, which is the United States, is more than that, it's beyond the 1.5 times 2.7, we know that yes, it is an outlier. And so from the histogram, you may have thought that it was an outlier, but using this method, will determine for sure whether it is or is not an outlier. Going on to activity 2, here you're going to be using this big set of data. These are those 34 countries from the previous activity. And instead of having you type all of these in, I have included a link to a Desmos calculator where you can use that to answer questions 1, 2, and 3. So do that and start again when you're ready. The problem that I want to talk about here to review is 3b. How did all those statistics change when you took out or deleted the value for the United States? That value was much higher, right? It was a high outlier. And so when you take that out, all of those values did decrease, some more than others, but they all went down a little bit. And really the big purpose of this activity was to show you how do those statistics change if you remove an outlier. Next, we're going to learn how to decide whether you should or should not remove the outlier. Okay, on to 14.3. Answer number 1 first on your own and start again when you're ready. Okay, starting with A, are any of the values outliers? So to do that, I found my interquartile range, which would be quartile 3 minus quartile 1. So I get 208. Take that times 1.5, so I get 312. I sketched a box plot here just to kind of visualize what's going on. And I see that my quartile 3 is 260, and so I need to see if there's any values that are plus 312 larger. So 260 plus 312, that's going to be 572. So any values that are over 572 are going to be outliers. And I can see in my data that there's going to be 3 of them. Now we haven't talked about this yet, but there can also be outliers on the low end. And so if I look at quartile 1, that's 52. I have to look this way, 312. So I have to really think 52 minus 312. Well, that's going to give me a negative number. There are no negative values here, so there's no outliers on the low end. Now, part B is where we start getting into a little gray area in statistics. Why do you think these outliers right here might exist? Now, this is looking at theft at different colleges in California. So perhaps these colleges are just in areas where there is more theft, or maybe the data was recorded during times of year where there's more theft. Whatever it might be, we have to think of what reasons that they occur. And then also, should they be included in an analysis of the data, or should we take them out? And again, this is a gray area a little bit. We have to think about, were there mistakes in collecting that data? Is that data valid? In this case, we don't know enough information about if there were mistakes, so we do have to keep the data there. Okay, going on to number 2. In these problems, you're just determining if it's appropriate to keep or remove the outlier when analyzing the data. So for example, in A here, they're rolling a number cube with sides 1 through 6. After rolling 15 times, this is the data that Tyler has. And I do see a number here that is possibly an outlier. And I do notice that that's not even a possible value to get when you roll a dice. And so this is a mistake in recording or some sort of mistake that Tyler made. And so in this case, we could throw this one out. Go ahead and do B and C. Start again when you're ready. In B, this number right here appears to be an outlier, but you know what? It is very possible that someone could have 12 siblings. So we would just have to go back and double check, was that a mistake or was that an actual value? And if it was a mistake, we could throw it out, but if it's an actual value, we would need to keep it. And then in C, this 0 appears that it might be an outlier. So again, we'd have to go back and check. Maybe they really did make 0 grams of biodiesel, or if it was a mistake, then we would need to throw it out. Okay, going on to the summary to wrap up lesson 14. The most important part of the summary is going to be right here. So circle or highlight or do something with that in your workbook. But they tell you how to calculate whether something truly is an outlier or not. And they have a nice diagram to remind you how to do that. Also, remember that once you find your outliers, you have to determine whether or not you can keep them and think about what those sources of error might be in that data collection. Going on to lesson 15, this is going to be one that you complete in Desmos. So go there and then come back and finish up the video when you're done. Here in the lesson summary for lesson 15, a couple things to make note of. They again review when is it right to use mean or median and when is it right to use standard deviation or IQR. So that's important. And then also just to be thinking about what can you get from different data representations. So for example, the dot plot is good here for showing us distribution, like is it symmetric or not symmetric, or is it bivariate. And then also the box plots down here are good for when you need like the median and the IQR. So different data representations are going to give you different information, so just keep that in mind.